Hello everyone. Today we are going to review our lessons on dilations. We just finished lessons 2 through 4 in Unit 2 and the quiz is right around the corner. So this will go into your interactive notebook and kind of summarizes all the big ideas that we came up with in class. So to get started, we're focusing on dilations. It's a transformation, so it's still part of that transformation group like a translation, reflection, rotation. The only thing different, it's not rigid. And rigid means that the size would stay the same. It never changes its size. The side lengths don't change. And in a dilation, we do notice that the size of the figure does change. So you'll see that all these little highlighted words, the highlighted words are the words that you're going to be writing into your notes, some of the most important phrases as you fill in your interactive notebook anchor chart. All right, so let's continue on. What stays the same in a dilation? So there are some things that do stay the same. The general shape stays the same. So if it is a triangle, an isosceles triangle, it'll still be an isosceles triangle. The angle measures, corresponding angle measures. We know what corresponding means. The same angle on the image should be the same angle on the original. Those angles would be the exact same measure if you were to measure them with a protractor. Same thing with the corresponding sides. The top side on a rectangle, and you look at the image of the top side of that rectangle, they should be parallel to each other. That's a great way to double check if you made a mistake in your math and your counting, is if you find out that they do something like this, then there's something that you did wrong. So you got to make sure that your lines are all parallel to each other as you are working. So what does change? So what changes on our dilations is the size of the figure. So it's either going to get smaller or it's going to get larger than the original. And then obviously if it gets smaller and larger, the side lengths have to also get smaller and larger. So those are the things that do change in a dilation. So our next part is, how does it change? So first of all, both the side lengths will grow and shrink according to a scale factor. So if you increase something twice its original size, the side lengths will also grow twice the original size. So what do we know about scale factor? We know that a scale factor that is greater than 1, that the image will get larger. And that means that it'll be farther away from the center of dilation. So if your center of dilation is right here and the image is going this way, it's going to get further and further away as the image is getting larger. Okay. If the scale factor is less than 1, that means we're dealing with a fractional scale factor. That means that that image is going to get smaller to the center. So if this was the center dot right here, it would get smaller to that center. And we also learned that if a figure has a scale factor of 1, anything times 1 is itself. So if it's itself, it does not move. And another little note about scale factor, a lot of times we have issues with our fractions. We can definitely look at a multiplying of a fraction, like if your scale factor was 1/2, how do we change that so we can work with it easily? Multiplying by 1/2 is the same thing as dividing by the reciprocal. So we can change the multiplication to the division, and then the fraction 1/2 turns into a 2, or 2/1. So you can always go into division. It makes it a little bit more easier. If you're ever stuck on your scale factor, you have a calculator you could always use in your toolbox. All right, so we talked about scale factors. So now the big part, how do we dilate? Okay, so the first step in dilating is that the first thing we have to do is we have to locate our center of dilation. Where is that center? That's our start. From there, we need to know what point we're dilating, or points. So depending on if it's a shape, you're going to have more than one point. So whatever points you're dilating, you're going to start with the center, and you're going to make sure that you are going through and you're dilating each and every point, starting with the center. So what we have to do next is make a ray. A ray should start at the center and go through every single one of those points that you are dilating. The next step is to measure the segments. Measure the segments between the center and the point you're dilating. So you're going to measure that distance. And there are several different ways that we learned on how to measure those distances. If you're dealing with a circular grid, we know on a circular grid you have to kind of count the lines that you are passing. So as you're passing those circular grids, you're going to count those little grid marks as you get to your point. On a square grid, there's a couple things you could do. We could count the lines like we do on a circular grid. And a lot of you practice that. Or we could use the slope method, and the slope method is the rise and the run. So in this one, we would count how far we would rise, so how far up we would have to go, and how far we would have to run to get from one point to another. So if I was going from this point to this point, how far up would we go, and how far over would we have to go to get there? So we can even put attached numbers. We can count our squares. So 2 to 3, kind of a example. Okay, if there was no grid, we could use a ruler and physically measure that segment out with our ruler, centimeters or inches side, whatever you feel works the best for you. Or you can use an index card where you just mark the segment and then move your index card that many segments as you go. So those are your options. And then the last part is to apply the scale factor. So you're either going to multiply or divide, depending on whether it's, a fraction or a whole number. And then you're just going to move the point. You're going to move that point as much as that scale factor tells you to move it. So let's take a look at some of our examples. At the bottom of the page, I try to put an example of each and every one of our displays. So I'm going to kind of cover these up so we're focusing on one at a time. All right, so the first one was what happens when there is no grid, and this was one right here. So the first thing you would do is you would draw your ray. Your ray was already given to you. We have to establish our scale factor of 2. We're going to start with our center of A. So we should probably add that to here, that our center was A. So let's add that to our notes. So we know what direction we're going to. We know what we're dilating. We're dilating B. So we might even want to write that down here and dilate B so that we can put C. So here we go. Our center is A. So there is our start. We are going to dilate B. So we have to measure this section right here. So with a ruler, I took a ruler and measured it as 1.8. If I took an index card, I would take my index card, line it up, and I would mark the start and the end. And then that index card is what I would move over, or I would measure it either way, whether the ruler or the index card works. And if the scale factor is 2, I'm going to be moving this over 2 places. So as you can see here, this would be 1 segment times 2 would be 2 segments. So that's where my location of C would be. Okay, so this was a measuring technique or the index card technique. Okay, the next one was our circular grid. So on our circular grid, make it a little bit bigger so it's easier for you to see. You can see we have our original shape is in the center, and then the image is on the outside, what we moved to. So in this one, you have to do the counting. That's the easiest, only real way to do this. So you're going to have to start at the center, and you're going to count out on the lines that you pass to get to B. So if you look here carefully, you can see I passed 1, 2, 3. So 3 lines. If I apply a scale factor of 2, 3 times 2 is 6, or you just add how many groups of 3? 2 groups of 3, and gets you to your B prime. And you do that to every single point, and you can kind of see the rays going through every point here. And you can do this one's also 3, and then 3 times 2 is another set of 3, which is 6. And then this one was 4 away from the center. 4 times 2 is 8, so you have to add another section of 4. Remember though, when you apply the scale factor, you always start back at the beginning. So if I did 2 times 4 is 8, I'm not going to start 8 here. You're going to start 8 at the center. 1, 2, 3, 4, 5, 6, 7, 8. All right. The next one is using a square grid. So they had 2 options with the square grid. You had the counting method, which I'm going to use here. And then on the next one, I'm going to show you the slope method real quickly. So you can see here, scale factor of 1/2. Here's our triangle. Again, you're counting the lines as you pass through. Half of 3 is 1.5. So you see where that point went. And half of 2 is 1, and you can kind of see where that point is, and half of 4 is 2. So here is a scale factor of 1/2. You see that it's closer to the center. You can also see that it is smaller than the original. And then this next one is a scale factor of 2. So you would take that exact same numbers from the original, and instead of dividing it, you're going to multiply it by 2, and you get your larger triangle on your image. Okay, so that was the counting method. And then the last one, I did a combination of the both. So here is my center, and we did these examples in class, so they should look familiar too. And we counted on out. So we did the counting method on these first two, and you can kind of see 5 times 2 is 10 and how I counted out. And you do have to make the rays. One reminder, make sure you're using those rulers on those rays, otherwise it will throw off where you're supposed to be landing. Okay, the bottom part, I actually did the rise and run. So I find out how far down and how far over I have to go to get from P to D. So I would go from P is down 2 and over 1. I apply my scale factor of 2. 2 times 2 is 4, so I'm going to go down all the way 4, and 1 times 2 is 2, and I go over 2. So you can see I take the rise and the run, multiply by the scale factor, and I get my new point. Same thing here. I can go over 5 and down 2. Multiply both those by 2. 5 times 2 is 10, so now I'm going to go over a total of 10 and down then a total of 4. So there's the rise and run method that you can be practicing. All right, so that summarizes everything. When you're done, glue this into your interactive notebook page, and you can go ahead and finish up your review, and we'll get ready for the quiz. All right, have a good day, guys. Bye.